Welcome back to 7th grade science. Today we're going to be talking about the law of conservation of energy. There are many different types of energy in the universe: light energy, sound energy, electromagnetic energy, electric energy, chemical energy, nuclear energy, heat energy, and the list goes on. In science, we're grateful that energy doesn't just stay in one form forever, but can be transformed or changed from one form into another form. When you clap your hands together, you're taking something moving, kinetic energy, of two objects and colliding them, which causes the energy of kinetic energy to come together and create something else, sound energy. As you can tell by my hair here, actually, that creates wind energy as well. And the energy that was at first kinetic becomes transformed into other forms of energy. When we start to calculate these forms of energy and how much energy they have, we find something interesting, and that's that the total amount of energy in a system is conserved in energy transformation. We made this into a law, and that law is called the law of conservation of energy. You can think of this law of energy in a simple form, and that's energy cannot be created or destroyed. Now, when we measure energy, we measure it in a unit called joules. So let's say we have this pen here, and it has 5 joules of potential energy. By dropping the pen, we then allow the pen to transform its potential energy into the energy of movement, kinetic energy. And when you measure how much kinetic energy is transformed from that potential energy, it's the same. Now, some energy is often said to be lost in such transformations, because if you were to drop a pen like this, obviously the pen is going to experience things like friction or air resistance or other elements that might cause the pen to slow down and not hit with as great a force as it could if there wasn't anything slowing it down. But the energy there is just another energy transformation. The total amount of energy is conserved. It's just transformed into different forms. And we can prove that in a video I'd like to show you of a professor demonstrating this fact and the law of conservation of energy in a pretty daring way.
Now I'm going to do the most dangerous experiment that I've ever done in my life. To demonstrate to you that I do believe in the conservation of energy. I'm going to stand against the wall so that my head cannot move back. And I'm going to release this object from my chin. And I let it swing. And if I don't give it a push, I will survive. But if I do give it a push, forget that lecture next week. This may be my last. This is no joke. If I gave it a push, it would have major consequences, and I therefore need your cooperation. I don't want you to speak. I don't want you to cough. I don't want you to sneeze. I don't want you to talk. I even prefer that you don't breathe. I'm going to count down from 3 to 0, and I don't want to hear any sound when I let it go. It's touching my skin now. Something you should know. Whenever I do this experiment, I never sleep well the night before. Something else you should know. When I do this experiment, I always close my eyes. 3, 2, 1, 0. Ah!
So with pendulums, as you can see from the image here, pendulums are a great example of how mechanical energy is a balance between potential energy or stored energy and energy of movement. Now, if you look at this image here, you can see that the GPE stands for gravitational potential energy and KE stands for kinetic energy. At the top of its swing, the pendulum doesn't have any motion energy or kinetic energy. It's all gravitational energy, and therefore when it starts to transform into kinetic energy, you can see that it falls, and at the bottom it has the most kinetic energy because it doesn't have that gravitational potential energy like it does at the top of the swing. In this way, you can see that mechanical energy is always an interplay of stored energy and energy of motion. And that energy, whether it's energy of motion or potential energy of motion, is always conserved. It is neither created nor destroyed. Thanks for watching. I hope after watching this video you'll have a little bit more understanding of how mechanical energy is an interplay between potential energy and kinetic energy, and that the law of conservation of energy states that matter cannot be created or destroyed. And we know that because we can see in energy transformations, the total amount of energy in a system is conserved. It's just transformed into different types.